Hello dear students, now let's begin with the chapter 3, that is crystal field theory. In last lecture, we discussed about valence bond theory. The use of hybridization as suggested by Pauling helped to interpret the geometry or the shapes of the complexes. No doubt, valence bond theory was quite simple and it easy to apply and make a good beginning to explain many things about the complexes. But it has various drawbacks also. Those drawbacks we already discussed in the chapter, but here also I have mentioned some. That VBT gives only qualitative explanation of structure, bonding and magnetic properties of complexes, but it fails to explain quantitative properties. It cannot explain spectra of complexes as well as detailed magnetic properties. It is assumed that according to VBT, all d orbitals are of equal energy, and it does not consider the splitting of d orbital energy level. VBT also fails to explain tetragonal and distorted octahedral geometry of the complexes. Moreover, it fails to explain high spin, low spin, inner, outer orbital complexes. To overcome all these difficulties, the new theory was proposed, and that was crystal field theory. The above said problems made it necessary to revise the ideas concerning the nature of bonding in complexes. So, the new theory called crystal field theory was first introduced by Bethe and Van Vleck in 1930, and they applied it to many ionic crystals. On the basis of this theory, a complex, here you can see, a complex is regarded as a group or aggregation of central metal ion surrounded by other ions. Central metal ion surrounded by other ions or molecules, and these other ions or molecules, they have electric dipoles, means positive and negative charge. And it is believed that the electric field of central ion will affect the surrounding ligands, while the combined field of surrounding ligand will also influence the electrons of central metal ion. Means electric field of this central metal ion, it will influence the surrounding ligands. At the same time, surrounding ligand also affect the charge on the central metal ion. The effect of ligand, the effect of these surrounding ligand is particularly marked on d electrons, d orbital electrons, which play large part in complex formation. And the influence of ligands, main important thing, the influence of ligand depend on their geometrical position in the complexes, whether they are in tetrahedral or they are in octahedral position. So that also affect the complex structure of the complexes. Now, in the simplest of the problem concerned, the bonding between the central ion and the ligand is regarded as purely ionic. This theory, crystal field theory, it does not consider the covalent bonding. It is completely based on the 100% ionic bonding. It does not consider covalent bonding, and this theory is considered as a crystal field theory. Later on, the modified treatment, which include the covalent bonding, is called ligand field theory. But in this chapter, we are discussing only about crystal field theory. Now, crystal field theory, it is based on various assumptions. The first assumption is, in a complex, the transition metal ion is placed in the center and it is surrounded by the ligands with lone pair of electron. Transition metal ion is present in the center and it is surrounded by ligands with lone pair of electron. Second assumption was the ligands are either negative ions or they are neutral molecules and they are considered as the point charges or they are electrical dipoles. There is no interaction between the metal orbitals and ligand orbitals. There is no interaction between metal orbitals and ligand orbitals. CFT, it is based on the assumption that the attraction between the metal ion and the ligand is purely electrostatic. CFT did not consider the covalent bonding, and it is based on the fact that the bond between the ligand and the metal, it is purely or it is 100% ionic. Next assumption is the electron of central metal ion are repelled by negative field of ligand and therefore metal electrons present in d orbital far away from the direction of ligand. Metal ion are repelled by negative field of ligand. The number of ligands and their arrangement around the metal ion determine the nature and strength of the crystal field. Whether ligands are 4 or 6 and their arrangement around the metal ion, whether they are in tetrahedral fashion or octahedral fashion, that determine the nature and strength of crystal field. And the last assumption, the degeneracy of d orbital of the free metal ion is removed by the ligands when complexes form. It is believed that d orbitals, they are of same energy, but when metal ion is surrounded by ligands, the degeneracy or equal energy of d orbital is removed. So all these assumptions we will see or we will discuss in detail. So crystal field theory is based on some assumptions like this. Remaining part we will discuss in next video.